since I'm a full stack developer consultant, I'm going to keep it a stack with you guys. Because the reality is, no matter how accurate and how optimized your choices regarding which database to use, the ultimate decision in reality, in the playing field, is going to be decided by generally three factors. So today I'm going to answer a question: how to decide which database to use. And this is something I get asked a lot. But before I dive into the answer, if we don't know each other, my name is Wissam. I am a full stack developer consultant. I've been in the field for over a decade now. Started back when PHP was king and jQuery was king. And today PHP is still king and jQuery is still king. So not much has changed. Not really. Well, a lot has changed, especially in the last couple of years. But throughout my experience, I've been working on a variety of projects, different organizations, different industries, you name it. I've also occupied different roles, from junior dev to full stack dev to team lead to architect. The past few months, I've been focusing more on the teaching of things. I find it quite enjoyable to help people with their career path. And I also see that people enjoy and get results from the advice that I provide. So that's me in a nutshell. If we were in geographical proximity, I would invite you for a coffee, or then we get to know each other a little bit more on a personal level. And that's something I do as well with certainly with the engineers that I coach one-to-one. But if you want to keep up with me, go ahead. You can find me on LinkedIn. You can find me on Instagram. You can find me on LinkedIn. You can find me on YouTube. And feel free to sign up for the course that I'm putting together. Link in the description. And so my goal is to, but in any case, so circling back to the question, before I dive into the answer, I want to apologize for my voice because, my throat hurts as hell right now, but I decided to still go ahead and do this video for y'all. And it might seem that I was, out partying or shouting in nightclubs or parties and stuff like that. Nothing like that. It might seem that I was, up working hard and hustling and stuff like that. Still not the case. So what actually happened? Well, let me let you in on the last 14 hours of my life. So yesterday in the evening, I got two boys, right? Two young kids. So I did the kids' game, put them to bed. We sat down, me and my wife. We watched a movie, and then things starting a little bit cozy, a little bit warm, So we went to bed. We had amazing sex. We went to sleep. Then baby decides to wake up around 2:30 in the morning. She was like, "Go handle it." So I get up, and the baby just wouldn't go back to sleep for 2.5 hours or so. So, that's me. I got up around, an hour ago or so. Had some shut eye, 5 hours or so. But I still feel tired, but I still decided to do this video for you all. So, going back to the topic of databases, it's really, really difficult to compress such a big topic in going back to the topic of databases, which database to use. it's really something that it's really tough to compress in a video of this size, but it's a huge topic, right? And so I'm gonna do my best to give you a 3-part framework to decide on which database to use, right? Very simple, high-level framework. Certainly aimed at people who don't have a lot of experience with databases. I work with a lot of front-enders and also back-end engineers who actually don't have a lot of experience, didn't have the opportunity to make decisions on at this level, what type of database to use for their projects. And so or even if you're, you have a side project, or you're setting up your own, web project, and you want to make some decisions on that topic, how to handle your data, what to do with your data, in which database system to use. So it's definitely not aimed at, seasoned veterans, people who have a lot of experience with databases, optimizing them. And so that's not the aim. The aim is just to give you today a very simple framework, just to get started, to get productive, to start, using a database right away, the right database, so you don't regret it later. Second, I'm not a guru. I'm not an expert in the topic of databases. It's a field on its own. I do have quite extensive experience, choosing databases, interacting with databases, even in some instances optimizing them, but in no way would I call myself an expert. So let's get into it. So right now, before, if you want to get into, this is actually a question that I like which database to use is a question I really like to ask during interviews, when I'm trying to hire developers, just to go through their thinking process, to see if they're, if you got any logic to your decision making, right? And if you know a little bit about the principles, which is really what matters in this case, the fundamentals. Ultimately, in probably 90% of the cases, 95% of the cases, as an engineer, as a developer, you will not have a lot to do directly with the actual provisioning, the actual maintenance, optimization. Databases usually, especially in big companies, there are teams, platform teams dedicated to such tasks. And so, but I still like I mentioned, to ask it during interviews. So going back to this, so what database to use, right? Long intro, right? What database to use? I'm gonna give you a 3-step, high-level, simple framework that consists of 3 parts. So first part is the what. Okay, the what. What. The second is the when. And the how is the last, or the third component of this framework. So in this 3-part framework, so the what, let's start with the what, shall we? So the what in this case refers to the data. What data, what information are you trying to store in your database, right? And when I say data, is looking at what kind of data you want to store. So there is the content of the data, the actual, information, but also, or the content, right? For the content, and the second part is the data model, right? Or the model, the structure of the data. So you hear this word data model a lot. Basically the structure. How do you want to structure this data, right? And so these 2 elements are going to dictate what database to use, because let's start with the info part or the content. What type of data? If you look at your domain, essentially, like what industry do you work on? What type of company, or you're working for? What type of organization? What type of data within that domain that you're trying to store and manage? It's going to help you look, during your research period, again, as a full stack engineer, or, if, at a startup scale, if you're trying to decide which database, if you're an architect at a bigger company trying to decide. So you're going to probably look at use cases or case studies from other industries. So let's say you're trying to, you're building, you're working on a project to store, for example, some reporting data, something with analytics, then it could be beneficial to look at what other companies in this specific, lane where they're trying, what database they use. So to do some research, right? So this is going to optimize your research. Okay, and then you can do some comparative studies and so forth. And so that's one. If you're looking, for example, for some, if you're storing data about money, right, transactions, banking data and so forth, that's another story. And it's probably just looking at this, just looking at the information part, the content that you're trying to store, the industry, it can help you narrow down the options. Okay, but this is not very, it's not a super technical aspect, but it's going to help you, weed out maybe some options that are not suitable for the task. The second thing, which is what I would expect you to know a little bit, especially during interviews, is the data model, right? And when I refer to data model, it's basically the structure. Do you have a predefined, a well-established and a well-defined data model, right? And this, let's say, for example, you want to manage some data about, let's say, about transactions, for example, banking transactions. In this case, chances are, if you look at your organization, the domain has already been established. You probably have some, information that is split up into, for example, like transaction tables, right? And you're starting to see where I'm going with this. Information, for example, about customers. We already know which information we want to store about the customers, which information we want to store about transactions, which information we want to store about accounts. This is well defined. The domain is well defined. So in this case, it makes sense to use some database that is, it helps maintain this type of structure, right? Generally, things like non-relational, in this case, things like, relational database systems are well suited for this task, not because of the data model, for other reasons as well that we're going to get into, but that's probably a good candidate, right? Now, let's move on to the when. So we talked about the what, which has to do with what data are you storing. I can't even write the one. iPad. And talk about the when. Here, when I talk about when, is when are you looking to read the data? When are you reading it? So, of course, as you get the data, as the data is generated throughout your, with your application, or if it's coming from third-party sources, it doesn't matter where data is coming from. You're going to have to store it, and at some point, you're going to have to read it, right? So when you want to read it, it's going to dictate, it's going to decide which database to use, because some databases are optimized for, you know, what we call immediate consistency. Okay, I'm just going to go down here. My God, man. If I can type, if I can write. When? Have you ever, noticed that you can't use a pen anymore? If you typed for so long, get used to the keyboard. I can't use a pen anymore. This is actually a good exercise for me because whenever I write on my iPad, it rewires my hands to actually, write letters, write words, the written word, I don't know if you, I'm going on a tangent here, but every time you want to learn something, something that matters, something that you want to remember, something that you want to wire up in your brain so it actually makes sense, it's better to use pen and paper. Something that it helped me so many times in my life, man. It's insane. Like even, for example, learning new languages. I'm talking about like languages, not programming languages, but languages. Right. Pen and paper. Or pen and iPad, right? So when? Let's go back to it. When? Read. When do you want to read the data? And this is going to determine whether you're looking for, eventual consistency. So the keyword here is consistency of the data. How accurate is the data? So there's two types of consistency. There is immediate and there is eventual consistency. I'll give you an example of that. So immediate consistency. Immediate consistency means that whenever you're inserting the data, you go and read it immediately after. You will see that the data is actually the way you stored it. Like it actually reflects data that you stored when you read, when you insert it, and after you insert it, go and read it, you're going to find that the data is accurate, right? It's consistent, right? So immediate consistency, right away, bam, insert the data, you read it, split second later, it's there. And the other type of consistency, that is eventual consistency, which means that you could, let's say this is your database. Let's say you can do an insert here. We're getting a little bit of into a little bit of a advanced topic here. So you do an insert, but you could go and read it a few seconds later. Then you get something else. Let's say, or the record is not, let's say insert a record, and you go and read it, it's probably not even there, right, yet. And you might be asking, Wissam, what do you mean by that? That's a good question. So in the context of distributed databases, and we're getting now into distributed databases, databases that are, they span across a network of nodes. They have different architectures. There's many of these. You can go and look up many distributed databases, many types of databases. But if it's distributed, it could happen. There are cases where some distributed databases are aimed to do eventual consistency, which means you go and insert it, the record, it might not even be there when you read it, which means that, when you do the insert, it's probably inserted in this node. But when you do a read, you're probably reading from a different node. The data is not there. The reason is because it takes time for these databases, this data, to propagate into other nodes. So it takes maybe a few minutes, a few seconds, or even a few hours to propagate this data, so that when you read it, it's there, right? And you might be asking, why don't we just propagate this thing quickly, this record this data right away, propagate it, and then it's consistent? The reason is because some databases are not optimized for this, right? So for example, if you look up Cassandra, for example, It's not optimized for that. It's aimed for eventual consistency. The reason the reason for this is it goes back to a very important principle, which is trade-offs. Trade-offs. Okay? Because the algorithms that are governing Cassandra, they're optimized for insertion. So Cassandra is optimized, for example, to insert very quickly. So you have a very fast insert, right? But a slow read, or eventual, it's not, the data is not going to be accurate right away. It might be accurate over time. And this is, if you worked on a analytics projects before, assume that you're, like a very common use case is analytics, right? Say you have a web application that collects data about a user, right? So the user comes in, they log in, they perform some operations, but you want to track those events. So you want to be creating some events, you're generating some events, and then you're inserting them, right? Now, that insert operation, you want it to be as seamless, as quick as possible, so that the experience or the performance of your web applications remains good, right? And so you want to be able to insert as fast as possible, okay? And reading the analytics data might not be high priority right away. You don't necessarily need to know all the analytics of all your users right away. You could wait, just wait a few hours until the data is actually collected and consistent. Then you can reason about it, right? So in this case, in Cassandra, for example, with these eventual consistency databases, they're good for this. They have fast inserts. The read, not so much. But again, does it matter? No. So in this case, it doesn't. But let's say you're working on an application, a banking application, right? Or like an ordering system, right? A food ordering system. In this case, you work with things like, with data that you want to be able to insert. You want to be able to commit the data into your database. Let's say some order information or the record. But when you want to read it, when you insert, this where input output is, right? Output, when you read the data, you want it to be, if you want to read the order, the order better be there, right? So let's say you insert the order via the app. Well, the kitchen staff who are fulfilling the order, they better see that order on their screens, right? The customer service better see that order on their screens. Otherwise, you have an unhappy customer. You're not going to tell them, well, I'm waiting for eventual consistency a few hours so that the data is there, right? You want to have, in this case, immediate consistency, right? And the reason, or, what is suitable in this case, a lot of databases are set up for immediate consistency. They can be relational or non-relational, right? Which is a good segue. And I probably should have talked about this topic of relational versus relational a little bit earlier in this video. But I wanted to show you there's other aspects to making your decisions about databases than relational versus non-relational. And so a lot of relationals, it doesn't matter if you pick relational or non-relational, in this case, a lot of them are optimized for, most of them are optimized for immediate consistency. Okay, so that shouldn't be a deciding factor, right? And so we talked now about the when the what. Now the how. The how is how do you want to how do you want to input the data, and how do you want to query the data, right? The how. And so maybe now is a good time as any to introduce relational versus non-relational databases. So relational databases are databases that structure the data using relationships between tables. And so, and this has to do with, if you remember, with the what. What are you storing? The data. So we talked about data model. And so relational databases, they organize the data in interrelated tables. So for example, at a high level, if you go back to that example of banking, so you could have a customer table, an account table, a transactions table, different tables that are related to each other. So this is where the word relational comes from. The types of relationships, they can be one-to-many relationships, one-to-one relationships, and many-to-many relationships. And I'm not going to get too deep into these types of relationships in this video because it's another topic on its own. There is a whole science behind it. But know that the relational databases, they are based on relationships between entities, between tables, okay? And they are optimized in such a way so that the data across these tables is consistent and it's not redundant. So it's not redundant. They're optimized in a way so that the data is, how do you say that, non-redundant and consistent. Okay, and this is really important for the use cases where relational makes sense. Non-relational. Okay, for relational databases, examples are, the Postgres, your MySQLs, your Oracles, etc. Those all are relational databases. Non-relational are usually either, document-based databases like the one that is most popular amongst front-end engineers, Mongo. I've been in interviews like, hey, tell me about your experience with databases. Just looking for, a high-level answer, and they say, well, I have experience with Mongo, right? That's a document-based database. There are other types of databases, the key-value pairs, for example, key-value pair-based databases like Redis, for instance. I think also Cassandra that we talked about earlier is a non-relational database for sure. And so these databases, they don't work on relationship. They don't take the data. The goal there is not to have non-redundant, consistent data. The goal is to be able to structure your data in a flexible way, right? And these the databases that fall in this specific, category, they're optimized for different use cases. So when you ask question, which database to use, relational, non-relational, it's going to depend on the use case, because there are types, there are cases where Redis makes more sense than a Mongo, for example. And as we shown, Cassandra makes more sense than a Redis, for instance. And so we have to look at the how. So let's go back a little bit to the how. And how are you looking to, so we talked a little about how to structure the data, relational versus non-relational. If your aim is consistency and non-redundancy, then you probably want to go for a relational database. Another aspect to the how is, how do you want to query? How are you looking to query this data? So if you're anticipating that you're going to run some, heavy queries that involve a lot of, relationships from different tables, then you probably want to pick something like relational and be able to optimize it in such a way that allows for these queries to run in a performant fashion. I'll explore this topic a little bit further in other videos. But for the sake, let's keep it simple here, right? Let's keep it simple for this specific context. Now, another thing that's really important with regards to the how is, how are you looking to insert the data, right? So let's look at this. And I want to introduce the topic of transactions here. Something that's really important to look up when it comes to transactions is the topic of ACID. Right? This is an acronym. I'll let you look it up. And so in the case where transaction consistency and accuracy is really important for your system, let's say for a banking application, then you want to pick databases that comply to these ACID principles. A transaction basically is a set of queries. So let's say there's an insert here, then you do another insert, then you do an insert. So all these are insertion queries that either run, the success of the whole transaction depends on the success of all the queries within. That's the simplest way I can put it. And so it's plain English. That's what it is. So let's say your system wants to implement a banking transaction when you have John and Meredith. I don't know, Meredith, right? So John wants to transfer money to Meredith, right? So you're going to go, John is going to, we're going to detract money, withdraw money from John's account, withdraw. And then we're going to take the money and put it in, let's say, in a temp account, in a temp storage, right? Then take the money and insert it to Meredith. Sounds dirty. Insert it into Meredith. Insert the money, the amount, into Meredith account, right? So this is a transaction. See, it's composed of many queries, insertion, many queries. And so if, for example, the withdraw from John works, this passes, that's great, but temp storage works, but then the insertion doesn't work, right? Then it means that the transaction has failed. You don't want to have a system that if any of these 3 queries fails, then you pronounce this transaction as a success. That's not gonna fly, right? So the rules governing transactions are all summarized within these ACID conventions and principles, and the database that you pick needs to comply with ACID and, implement it in a correct fashion, right? So let's zoom out a little bit. We talked about the three parts, right? The what, which has to do what data you're trying to store. The when is when are you trying to read it, and has something that's basically the consistency aspect of the data. And how has to do with how are you looking to structure that data? How do you want to insert it, which is transactions, and how are you looking to query that data, right? So I want to talk about one more topic, and that is, in my mind, databases are split into two types of databases. And I should probably started with this topic again at the top of this video, but now better late than never, right? And categorize them into two types of databases. There's general purpose and use case specific. So general purpose databases are databases that can be used for different types of use cases, different types of data and so forth, and they can still function. And some of them are the Postgres, the SQLs, the Mongos, the Redis, and all these databases are, general purpose. They're known for some use cases more than others. For example, in the case of Redis, used a lot for caching, but you can use it for other reasons as well. But these are general purpose. They're not made, and I'm not saying their general purpose means that you can, no matter what your constraints are, you can still use any of these. That's not what I mean. What I mean is that the type of data or the domain doesn't always, is not, they're optimized for many domains and many use cases, right? Use specific databases or use case specific databases are databases that are actually built for a specific use case in mind, right? So, for example, for graph shaped data, for instance, really, if you're looking, for example, to store some data about, like, let's say, some entities that are laid out in sort of like a network or a graph or something like that, like Neo4j is a good candidate, because again, the people who've built it, they have used algorithms under the hood to optimize better inserts, better reads, better querying for that data when you store it in such a database system, right? Another example is Prometheus, and these are used generally for observability. I don't know if you heard, if you're working for one of the big companies, Prometheus is used for storing data. That is temporal data, like time series data, right? So let's say there's an event that happens at midnight, then there's event that is stored at 12 noon, right? And then 13. These are like data that has a timestamp, and you want to be able to go back in time and the different operations. I haven't used a lot of Prometheus firsthand, but the first use case for Prometheus is time series-based data, right? If you're storing data about like geospatial stuff, geographical stuff, like maps and so forth. There's systems that are optimized for this, like ArcGIS, for geo data. You look it up. So again, there are databases that are built with specific use case in mind, and they're optimized for that specific use case. And if you do happen to have, building a project that falls within that case, then you're in luck because there's something already. So that being said, like I talked for about like 40 minutes now. These are all, I get. So in the past 40 minutes, I gave you a kind of like a framework to make sensible, technical, decision about what type of database to use, right? But since I'm a full stack developer consultant, I'm gonna keep it a stack with you guys because the reality is, no matter how accurate and how optimized your choices regarding which database to use, the ultimate decision in reality, in the playing field, is going to be decided by generally three factors. Okay. Number one is your platform team. That's the team who is in charge of, the infrastructure, setting up IT systems and so forth within the organization. This is especially important if you're working for big organizations, because they usually have a team or teams in charge of this. And these guys are the ones who are, it's like the gatekeepers. Any new system that's going to have to be onboarded is going to have to go through them, right? Assuming that none of the existing choices within like the type of database that they use, for example, let's say they're using Oracle and some MongoDB on the side with some Redis for caching. Let's say you want to come up and say, I want to use Neo4j, right, as as a choice for my graph-based project. Probably their first instinct to say no. That's not going to happen, right? And it's for many reasons, right? One of them is laziness. Another one is probably politics, budget. In other cases, it has to do with data governance and privacy. So for some organizations, let's say that are European Union based, they don't want their data stored somewhere else. And so, that's a hard requirement. But in other cases, you can, play the politics game and try to force your choice if it's really, really worth it. In most cases, though, or in some, you could, try to see if there's a trade-off to be made with regards to your use case, and see if you can use something that is already, being used, right? That's why I mentioned the general purpose databases earlier that can be used for different, use cases. If you're working for smaller organizations like a startup or scale up, or the most, I would say the dictating factor there is budget. How much is it going to cost us to set up the system? Can we repurpose it and use it for other things? Yeah, that's a big one, right? And so, again, thank you so much for watching this video, where I gave you sort of like a general oversimplified framework to answer the question of which database to use for your project. If you derived any value at all from this video, hit that like button and subscribe to this channel. Do videos like this all the time. And if you want to dig deeper as a engineer who want to expand your knowledge beyond what you're currently doing, you want to increase your marketability, You want to increase your value in the market. You want to earn more.